Hey everybody, just wanted to make this quick video on how to make great looking schematics for your papers and other documents. So first thing to understand here is the difference between vector drawings and raster drawings. So you can see the same schematic is being shown here. On the left, it's in a raster format. It's a PNG file. And raster formats essentially are defined pixel by pixel. These include JPEGs, PNG files, TIFF files, uh, GIF files. And the point is, because they're defined pixel by pixel, if you zoom in far enough, eventually you'll see the individual pixels, and they don't look great, especially black and white lines and text. Another problem you have is because these file formats are defined pixel by pixel, the file size would get huge if you define them at a fine enough resolution that they'll look good. And so to prevent the file size from getting huge, usually some compression is applied, and so then with lines and text, you start seeing these sort of gray, blurry artifacts around the edges of them, depending on the amount of compression applied. So generally, these are not good file formats to use for line drawings and drawings of text. Vector drawings, example here shown on the right, include file formats like PDF and SVG. So in these cases, paths are defined by their vertices and points along them, and the sort of line thickness and color that are connecting them. Areas in vector drawing programs are defined by the vertices that bound them and the colors and shades that are used to fill them. And text is handled as text objects. So the text is actually included in the file description. So 3MA in this case would be used to define this object here, and the font style and so on is specified. So as a result, these look great at any zoom level. That's why a properly developed PDF file looks really great at any zoom level. Um, so you really want to, generate your schematics and block diagrams in a vector file format. Note that a lot of vector file formats, like PDFs, have provisions that allow raster images, like PNG files, to be embedded within them, but this doesn't fix the problem. If you embed a PNG file in a PDF file uh, that is created, for example, with LaTeX, still you're ultimately limited by the original source file, obviously, right? So it'll still, the embedded file will still look like crap if you zoom in far enough. So really important to create your drawings natively using vector drawing programs. So Inkscape is an open source cross-platform vector drawing tool. And what you want to do when you're creating these is start with a nice symbol library. So here I've got my symbol library for electronics drawings. I've got all the components defined on a consistent grid scale and with a consistent line width. That's going to create a consistent look across all your figures. So I've specified the grid spacing and the line width that you want to use. The line color is obvious, it's just black here. And so before you start, I think it's good to just make sure that you're sticking with that specified grid spacing and line type. So you can do that by going over here to File and Document Properties, and just check over here on the grid spacing. So you see I've specified 2.5 millimeter grid spacing in my template, and I've got my grid spacing 2.5 millimeters specified here. I also like to go and edit preferences and set the default um, line types for all my shapes to be consistent. This is a little confusing here because I've indicated in my template that 2-point line thicknesses are going to be my line type so that all the lines are the same width throughout my drawing. And here the stroke that's being specified is 2.67. That's because it's in a different unit. It's in units of pixels. You can see if I hover here, it says 2.667 px, which is not the same as specifying it in points. So just watch out for that. Um, so I went and I did this for all my sort of standard shapes in my pen and pencil tools. They all have this default stroke type. that's consistent with my template. Okay, other thing I'm going to do when if you first install and launch Inkscape, it may not look exactly the same here. Your toolbars may not all be displayed. They may be in different places. Um, I like to just display them all, but in particular, I think ones that I'm going to be discussing here are the Snap controls bar and the Tool controls bar. You definitely want to have those turned on to be able to follow along here. Okay, so first thing is let's talk about just drawing wires here. So I like to use this tool here, the Bezier curves tool for drawing wires in a schematic. That's because it lets you draw a multi-segment wire continuously. And you'll see that I'm snapping to the grid. We'll discuss snapping shortly. But with each vertex here of the path, I'm just left clicking once. And then when I'm done, I right click. Make sure you just click once in order to draw these lines. Don't click and drag. That has a very different effect, obviously, as you can tell here with the Bezier tool. It's not generally what you want. Usually we draw wires with a sort of Manhattan style geometry in schematics. Okay, so other thing to watch out for, it may be tempting to use the pencil tool and draw your lines one segment at a time. And it may look like this is working okay for you, right? And it can seem simple, but in fact, again, if you zoom in close enough, you can have problems at the corners, depending on how you define the line caps. So actually, it combined these pencils tools into one path, but let me show another example here where this can get messed up. What can happen sometimes is you create two line segments with the pencil tool, and then at a corner between them, you get this funny looking gap, right? And so you don't want that. You can kind of address this by changing the line cap style. So that's kind of a workaround if you've got a problem that you want to fix. But instead, a much better way to handle it is to just draw the whole path with the Bezier tool. Okay, then you get the nice corners all the time. Now, oftentimes in schematics, you're going to encounter a situation where two lines may cross at an intersection point. So a couple different ways you can handle this. The easiest one is if you use Control Click, you can place a dot in your drawing. Let's see if I can get that working there. With the pencil tool. So I turn on the pencil tool and I hit Control Click, and boom, you get a nice dot there. You can define the size of that dot back in your preferences tool. Um, so that's a quick way to just put dots all over the place at connection points in your schematic. I've also included in my template here a connection dot, as well as this shape here, which is an open circle that's used to indicate a port in your schematic. Okay, so next let's talk about how you move shapes around. So this is one of the trickiest parts of creating and editing vector drawings, and that's because you want to be very careful about the snapping that you use. So let's get rid of that. So when you drag shapes around in Inkscape, the snap point is the point of the shape that is being snapped to the grid, and it is highlighted with a little red cross here as I'm dragging it around the schematic. So it's that red cross that is being snapped to the grid in this case. Now, the point that's snapping depends on where I initially grab the shape. It could be any of the vertices or even other points in the shape. If I grab it over here, it'll be that vertex that's snapping to the grid. So when you start dragging a shape around, you want to be really mindful of where the red cross is. That's the point that's going to be snapping. Now this gets particularly tricky when you're dragging around a complicated shape, like let's say an op amp like this, or a transistor. So if I grab this in the wrong place, see where the red cross is? It's actually the plus sign that's snapping, and that may not be what you want. Instead, in that case, I'm going to take care to make sure I grab it, and you'll notice here, right, because I was snapping with the plus sign, you can see the problem arising, that the end of this wire has not snapped to a grid point, which is probably what I want to do. So instead, when you grab the shape, grab it near the point that you want to snap. And then when you do that, you can abut it against the wire, and then it all lines up perfectly. See, with no gap in between, and the lines are all the same width. So again, same goes for transistor symbols. I'll just show you a little example here. If you want to connect this transistor up here, you're going to make sure you grab it by the proper point here. You can get into particularly bad problems if you start dragging a transistor around and try to drag it by the gate. You may not end up with the desired result. You'll see now the snap point is not the middle of the gate here, but it's actually the side of the gate. So that may not be what you want. Now I've created this symbol library so that if you accidentally grab by the edge of the gate, it still works out okay, but you want to really watch out for that. Okay. So generally, the snap behavior of Inkscape is controlled by the snapping toolbar here, and it's quite complicated. The top button here just enables and disables snapping altogether. You don't want to disable snapping. If you do that, then you can start putting things off grid, and if you put a couple shapes down off grid, it can be pretty hard to recover from that. So keep snapping on at all times. Okay. And I always keep this on over here, which is snap to grid. I've defined my grid with the proper spacing, 2.5 millimeters in this case. So I'm always snapping to grids. And then these buttons here define which parts of a shape are snapping to the grid. So for most of the time, I want to snap nodes to the grid. So what that means is that any, for example, with this button turned on, any corners, any vertices of paths, so-called cusp nodes, will be, I can become sort of drag points that snap to the grid, depending on which one I grab. Okay. So that's generally my desired behavior for most of the items here. Resistor, right? I probably, and you want to zoom in and make sure you're defining the right, you're grabbing the right snap point. If I grab the end of the resistor, right, that's a vertex in this path. I want to snap it to the grid. So I usually keep these points as being the selection points for my snapping. An exception is something with circles, right, where it's kind of a circular shape that I want to snap. So here's an example here, right, this guy or this guy. You'll see that the snap point is actually a point on the perimeter of the circle. And that's not what I actually want snapping to the grid in these cases. It's actually the center of the circle that I want snapped to the grid. So when I'm dragging these kind of shapes around, I turn off this selection, and instead I activate this one down here, which snaps some other points of the shape to the grid. And in particular, I activate this one here, which says snap centers of objects to the grid. So now that's going to give me my more desired behavior here, right? Where I can, oops, grab the wrong one here. I'm going to grab this one. Now I'm snapping the center to the grid. So that's going to be much better for dragging circles around, right? So here I want to define a port. I'll just show you another quick tip here is you probably want that object on top here so that the port looks proper on top of the line here. Okay, So now you just got to remember that's why I keep this toolbar active. I'm constantly switching back and forth between different snapping points depending on whether I'm moving around a circle. Most of the time I'm just moving around lines and symbols like triangles and transistor symbols. In those cases, generally I want to snap the vertices of the shape or the vertices of paths to the grid. So this is going to be my normal setting. I really just switch to this one down here when I want to move circles around. Okay, now if you want to kind of change the gravity of the snap, right, like how close you have to be to snap to a point, that is another setting you can play with in Edit Preferences here. If you go down to Preferences, there is an option here for changing the snap spacing. Actually, it's maybe under File, Document Properties. There's a couple different places you can play with. Here you go. Snap only one closer than this. So this sort of uh, drag bar lets you select sort of the strength of the gravity in the snapping. So that can be useful too. Okay. Um, so snapping is really important when you're moving objects around. And another useful thing to do when you're moving objects around is to group them. So here I'm going to select all these objects together, the resistor, this complicated wire I've drawn, and the connection dot and port symbol here, and I'm just going to group them with Control G. Now they become one object that I can move around together. When I'm moving them around, I want to be mindful of where do I grab them, because where I grab them defines the point that's going to snap to my grid. Okay, but that makes it a lot easier to create complicated shapes and keep them together. In fact, this whole op-amp symbol here is a grouped shape, obviously. Okay, so grouping is really useful. You can always go and ungroup shapes later with Control Shift G. Okay, now they're ungrouped again. Now this complicated path I drew here, another final point is it can be useful at times to edit paths like this one point at a time. There is a tool for that. Right, so now I can just grab one corner here and move it around. Okay, still want to keep snapping on, of course, so that it's always at a point on your grid here. Okay. Now another common thing you may want to do is stretch things out. So, for example, let's say you've drawn a wire here connecting to this resistor, and then you realize it's not long enough because maybe you want to put your capacitor over here, and the wire doesn't reach anymore. So you want to move it, you want to stretch it out. There's a couple different ways you can do it. You can drag the point over. That's one way. But another thing you may get tempted to do is just drag it out here. That's fine too. Just very important that you have this setting disabled here. It says when scaling objects, scale the stroke width by the same proportion. You want to make sure that's turned off. Just to illustrate the issue here, let's say you've got a transistor symbol that you want to make bigger. If I have this turned on, okay, you'll see that when I make the transistor symbol bigger, the line widths also got bigger. So now these line widths don't really match up with the line widths of my wires. So it's gonna look kind of weird, right? When I try and match this up with a wire over here. Right? At the connection point here, the line widths don't match. So instead, if I had done that properly, I don't have this enabled, if I stretch out the transistor symbol, the line widths will stay at my constant 2-point standard definition. So then, looks great when I go and connect it to my line. My line widths are still all the same, right? Maybe a better example is here, right? You can see the line widths are still exactly the same. So that's very, very important, right? When you're moving things around, make sure you have this guide disabled. You generally want to be really careful in any case about resizing symbols like that are already pre-baked in your template, like transistor symbols. But if you have this enabled, you can also get weird behavior like when you stretch a path, right? You'll see the line will actually get fatter because you've stretched this path around. Now some of these path widths are not going to be 2-point width anymore. You can see they're a little fatter than these lines. So that's going to create problems too. So just generally, you want to keep this turned off so that your line widths always stay at 2-point. Okay. Next thing just to point out, we're almost at the end here. I will just point out another cool feature, especially if you're creating drawings to go into a LaTeX document. There's a cool feature here that let me see where it is. Under render mathematics. Okay, so this is a feature that actually allows you to enter an equation or even just a symbol in LaTeX format here and embed it in your Inkscape drawing. So when I click apply, it's actually launching LaTeX in the background, parsing my LaTeX code here. This one's pretty complicated, so it's just going to take a sec. And it's going to create an object in my vector drawing here in Inkscape that is, corresponds to this equation in LaTeX format. So this requires you to have LaTeX installed somewhere, obviously. But once it's done, you've got this nice looking LaTeX equation. So this, is nice because LaTeX uses a very particular font style for its equations. And so if you're embedding this figure in a LaTeX document, the mathematical symbols will look the same in your figures and in the text of your document. So you can use that even to embed just an individual symbol like a lambda or theta, right? Just so that it looks exactly the same as it does in your LaTeX document. So that's a cool feature. And this document is even, kind of stretchable. Now, if you really want to, you probably want to have control activated so it, hold down control while you're resizing it so that everything scales in proportion. It still looks great. Okay, so once you've prepared a drawing that you're happy with in Inkscape, now it comes time to export it in a format that can be incorporated into your other document. So first, you always want to save it in Inkscape's native file format, which is an SVG file. So go ahead and save a copy there. That's fine. So that allows you to always reopen the document in Inkscape and make changes to it and re-export to the other file formats if needed. If you want a version of the drawing for use in a Word document or PowerPoint or maybe for embedding in an email, best way to do that might be to just export it as a PNG file, which is a raster file format. So you're going to lose the file quality, but that's okay. You've got the source file still saved as an SVG file if you need that. So if you're going to do that, you can select specific parts of your drawing to export. So I'm gonna, let's say, select this part of my drawing, and then export only the selection here. And you've got some options here. You can select the image quality by specifying the dots per inch over here. So if I go ahead and export to, let's make this easy to find here. Okay. Let's say I export it over here. The default is usually 96 or about 96 dots per inch, but I just want to show you what that looks like. So here's the exported PNG file, and at 96 dots per inch, you see that it looks pretty terrible. Okay, so instead, you definitely want to specify a higher resolution here. Used to be the case, really, that raster image files were fine when the primary vehicle for reading documents was hard copy format. So as long as you specified a dots per inch resolution that was at least as good as your typical printer resolution, then it really didn't matter whether it was a vector format or a raster format. But these days, people are typically viewing documents digitally, and they can zoom in as much as they want, so it's important that it look good. So if you need to go to a raster format, at least 300 dots per inch. Of course, this is going to imply a larger file size, but that's one of the reasons why we would prefer vector drawing formats where possible. But at 300 dots per inch, often you can get a file quality that's kind of passable. I'll just show you here what it looks like. Right? Again, looks much better than before, but still, if I zoom in far enough, I will see, right, these artifacts, the gray lines around the borders here. So not as good as a vector format, but again, for some office products or for just embedding in an email, this can be an easy way to do it. However, if you're trying to generate a high quality PDF ultimately for a thesis or a paper submission, then instead you're going to want to export it in a vector format that can be easily embedded into, let's say, a LaTeX document. So to do that, one way to do it is to save a copy. And you can, for example, export a PDF file. Okay. Now the problem here, if I do this, it's going to save the entire document. There's no easy way to just save a selection to a PDF format. So when you're ready to do this, what I recommend you do is you actually go ahead and delete all the other stuff from your drawing that you don't need. I'm going to delete all that, delete this, delete all this stuff. Now, let's say that's just the specific part of the document that I finally want to embed. So I go ahead and save a copy of that, and I specify PDF file format. And when I do that, it's going to present me with a secondary dialog here. So this is important. If I just export using the document's page size, what it's going to do is create a PDF that is the size of the whole page, and it's just going to have, mostly white space with a little bit of figure in it. But if I'm going to embed this in a LaTeX file, I really just want the PDF bounding box to be the same, as the actual objects that I include in the figure. So instead, I'm going to use the exported object size here. If I make that selection, oh, so I had a bad, let me just do that again. Go to PDF here, save, and I had a bad setting down here. I got to get rid of this. Okay, so it's exporting that, and let me show you what it looks like here. Right? So here, I've got a nice PDF file. It's bounded just to the limits of my figure, and it's gonna look great at any zoom level here. Right? Doesn't matter how far in I zoom, it just, because it's a vector format, it can kind of interpolate all the points, even the curved edges, right? They all look great at any zoom level. So that's it. Hope that's helpful for you. Uh, and yep, see you next time.